All right, so the first announcement is that Quiz 2 will be on Monday, November 14. And what I'm doing for Quiz 2, I created a link here. This is an active link, Quiz 2. And on here, I'm providing 3 of the 5 questions that I will ask on Monday. So this will help get you prepared for Quiz 2. So here I have a class called Bean Jar, and I have most of the code to it, but some pieces of code are missing. And 2 of the problems are to complete the missing code, and one of the problems is to draw the UML class diagram for this class. And these are 3 questions that will appear on the quiz, just as they're shown here in the web page. And then there's 2 additional questions that are related to the Bean Jar class. Yeah.
We will be writing them here in class.
You're going to write here in class. But see, I know that the topic of classes and objects is a difficult subject, right? It's a difficult topic, and it's hard for people to fully grasp it. It's abstract and just tough, and so I want to, give you as much preparation as I can to be able to do well on the quiz. All right. So make sure that you review the material that we covered in the last 2 lectures, and that you prepare for the quiz by studying this problem that I have on the website. Now for assignment 3, I asked my grader, Jaron Willis, to accept late submissions on assignment 3. I didn't give him a date though, but pretty much, I would get that done today or perhaps by the weekend. Get assignment 3 done. We won't accept submissions after probably the weekend sometime at the latest. So one of the problems with assignment 3 was exercise 3 here. And what I did there is I modified it slightly. So the random prime number that I want you to generate should fall between 2 and 1,000. So we just allow any integer to be a candidate prime number, then the algorithm that we're using is too slow, because our algorithm it does a linear search from 2 through up to the number that we're testing to see if it's prime or not. And it takes too long for a general integer to be verified as prime or not. So let's restrict the range from 2 to 1,000. And then the other change that I made was adding this snippet of code here to show how to convert an integer to a string. Now, not everybody's going to need this, because if you look at the example code that we covered in lecture and in lab, that there's 2 possible solutions. And one solution is you generate the random web page inside the print method. The other solution is you have a string, maybe it's called HTML, that's what we called it when we worked out that problem. We have a string and we keep appending text onto the string, and then when we call print, we just print the string. So in that second approach to solving the problem, you're faced with this issue of generating a random number, x in this case, and then appending it onto the end of the string that you're building. So we didn't cover how to do that, and I'm showing you one approach to doing that. It's using called the string stream class. We declare an instance of string stream here, and then we use that output operator, and we write x into the string stream, and then we invoke the str function or string function on that string stream object to get that value for x as a string. And that's one procedure to use to convert a number to a string. In other languages, in all other languages actually, it's much easier to convert an integer to a string, but in C++ it's messy. So that's that. And then what I'd like to do today is move on to Lab 7. But are there any questions? Yeah. And Lab 7 is due today. That's right. Let's see. Is that too early for Lab 7? Or should we, maybe I'll delay it to Monday. So make that due on the 14th. Does that make sense? It gives you 2 labs to do it. Get it done. And I'm going to work problems out today, so I'm going to show you how to do it.
Lab 6 exercise 1, I talk to you in class. Every time I run it, it gives me the web page, but it also gives me an error after it runs.
Yeah. Let's take a look at your code, okay? All right.
It's on.
It's in the repository, right?
Yeah.
All right, let's take a look at that. Let's take a look at... You're going to need to give me your username.
Bradley?
Like that? No E? Like that?
Is that an L or an R right there?
Oh, Bradley. Yeah, Bradley. Sorry.
B-R-A-D-L-E-Y, and then Barnhart. Barnhart? B-A-R-N-H-A-R-T. There should be E after the L in the first name.
So exercise 1, problem 1, this one?
Yeah.
All right, let's take a look at this. So here's the let's take a look at the problem. I know I'm supposed to do this. Right, change settings. All right, so this is exercise 1-1. What does that mean? So this should be, that doesn't matter. This is exercise assignment 3, problem 1.
Should be lab 6.
Oh, it's lab 6? Oh, I see, I'm sorry. Lab 6, exercise 1?
Yeah.
Yeah, okay. Lab 6, exercise 1. Let me name that. So it's assignment 6-1. I think I had you do this, right?
Yeah.
All right. Okay. So this, let's see what to do here. So reorganize your solution to Lab 5 Exercise 1 so that the code is object-oriented. So this is a web page that prints a list of random color values. Is that right? Okay. So let's try to build it. Let's build it. So when we build it, we have to include all of the implementation files on the command line. And now let's run it. So it runs, and then we get an error. Terminate called after throwing an instance of std logic error what? Basic string s construct null not valid aborted. That's hard to understand, isn't it? And I don't know exactly what the problem is by looking at that. Null is not valid in the basic string. All right, let's take a look. Let's go through a a problem-solving session together on this. Now, so it's a runtime error. So let's do this. Let's just comment out everything except for the return statement. Save that. And let's build. So this should run, right? It's a runtime error. We commented out all the significant parts of the code that would run. So nothing runs. Or the web page object is never created. We don't call any functions on it. It's not created. We'll just return 0. I'm just starting. I'm not kind of resetting back to a blank slate here. So we built this, and of course it runs, right? That's what we expected. So let's do this. Let's just call the web page constructor. See if that's all right. No problem. Okay. So I'm just going to walk forward here and sort of execute additional code and try to isolate where the problem is. I'm going to drop it down to here. Let's not call print on web page. Let's just call this stuff here. And I'm sure that this is already running. I'm just doing this as just sort of warming up to this disciplined approach of trying to identify where the problem is occurring. So that seems to be okay. Well, this should fail, right? This is where the failure happens. Okay. There it is. So we got a failure. In fact, you can see probably it's after printing this line here, we're going to try to do something else. So let's look inside the implementation for print in the web page class. We just call getRandomColor. That prints the whole web page? See, I wouldn't give it that name, right? It's not a good name for that. You know, that you should give out a different name. Call it something else. GetRandomColor. So actually all of this code here should be this string I don't see a reason for this get random color function. I would put all of this up in here. Right? This doesn't make any sense. You're in a print function that says get random color, and that's what prints the.
Right. Well, that's how I understood it when I was in the lab.
Huh?
That's how I understood.
I see. Well, you know, it runs, but it's not a good name. It's not a good organization. It doesn't convey the logic very well. All right. So that's something that you need to work on. That's something that that we grade for. If it's not a well constructed, well named, well organized piece of code, then it's not going to get full credit. But anyway, this is let's focus on the bug. Let's see where that's occurring. So we go into this loop, and we call this this get random hex digit function here. I'm going to comment that out and see whether it still crashes or not. Oops, it won't even compile. That's because this line depends on color being defined, which is right here. See? So it's no longer defined here. So this, I think this should run. It doesn't run. There's still a problem there. So the problem is not in that any code that we commented out. So we loop through here and we print this value 100 times. All right, so these are not even being called anymore. Am I doing that right? That's get random color here. Watch this. Let's take this out. That's okay. Somehow when we call get random color, which is down here, now this, oh I see, this is declared as returning a string. But you're returning a 0 here, that's not a string. See, if you had worked on getting the name better and organizing the code, you wouldn't have to focus on doing this debugging, because it would have emerged that, oh, I don't need a return value here. Why we don't need to return a string? Because we don't do anything with it in here. Of course, you could do this. Now we're returning a string. Of course, we don't use it, right? So it doesn't. We can get the program to work, but we probably wouldn't be able to build a large program on, with this kind of a programming habit. Question?
By returning an empty string, is that going to slow the program down?
Not in a noticeable way. If you return an empty string 1,000,000 times, maybe that would be a consideration at that point. So that's it. Look, see, it cleared the screen because we printed 100 new line characters. And it looks good now. We have to uncomment this thing. Remember, these all should be indented in a consistent way. Of course, you probably have tabs in there, right? So my tabs, see, that's why I recommend to people not to use tabs. Because in different tools, the code will look differently. It's not totally wrong to use tabs, though. Is this just I've noticed that In some teams, they don't use tabs because team members are using different tools to look at the text files, and they get displayed differently if you have tabs in there. Okay, now this problem is definitely not done here because the code is not well expressed. So let's do it like this. Let's move this up here. Let's take these 7 lines and put them up here inside print. Now let's look at what this does here. So we go through this loop. We get a random hex digit, and then actually we get a random, so this is not a random hex digit either. This is a random like hex string. A hex digit is 1 digit. It's not a whole string. Just wanted to get it to run. Yeah. But see, now this is the point I'm making over and over again. Don't just get it to run. As you're building the code, make sure that it's clean. At every point along the way, you need to refactor. You need to reorganize, make sure your names make sense, and make sure that the structure of the code makes sense. Get your indentation working correctly. That's part of the problem-solving process. Don't do it at the end. It'll take longer to get the job done. Do it as a part of the problem-solving process. This is the point. I've made this before, making it over and over again because I've seen this happen. I've got that experience of all those years of doing this. So keep that as a lesson if you can. Yeah.
I kept doing that when he was doing it, and I get lost. And so what I started doing is I started looking up when I was reading the book, because that was actually really hard for me to read online.
Yeah.
And I found a website. It's called c++.com. It has tutorials, and it just kind of broke it down, and that way I could see, the different parts, and then I could format them correctly, and it flows better.
Yeah, that sounds great. That's a nice story. It's called C. There it is. There's a recommendation. Okay. Yeah, I've been to this site, and this looks good. This looks great. That's great. Okay, let's. Yeah.
Can I ask one question?
Yeah.
How can I add a member function to my number class?
How can you add a member function?
Yeah, I wrote a whole program, but I just don't know how to add that member function.
Oh, how to add a member function? Well,
Member function to the number class for exercise 2 of assignment 3. I just want to get that one part.
Let me do this. I'm going to show you with. Wait a minute. I'll show you how to do it with exercise 1 in assignment 6. Okay. I'm sorry. I'm going to go into this folder. How to add a member function. Let's do it in 3 steps. Okay? First step is this a great question? And that's why I'm happy that you asked this question, and I want to answer it. I would do this in 3 steps. How to add a member function. First of all, let's write code that uses the member function, that calls it, so we can see how it's intended to be used. All right, let's suppose the member function is, say, print. Is print in the number class? Print is not in the number class. Let's do it like this. After we have the, I'll do it at the bottom here. After we print this line, We have an object called 2, which we create up here. Right? Let's call print, and that's a new function. That would be a new member function. That's how you would use a new member function. You would call it with a dot operator.
Wouldn't I put that in header.a?
This is step 1. That's step 2. My step 2. You can do it in a different way. So just be patient with me. I'm going to show you step by step. So this is what it would look like in use, right? So we have a member function. How are we going to use it? Well, this is what it would look like if we were to use it. We invoke it with a dot operator. Okay, now we have an idea of how we would want to use it. And, you know, it's supposed to print the value of the number. Let's add it in here. It's a public function, and it's called print. It's a public function, so we put it in the public section. It looks like one of these other functions. The print function doesn't return a value. We don't need to use anything that it returns. We just call print like that. We declare it as, it doesn't take any arguments and it doesn't return a value. Okay, now, a third step, we added it to the header file. Now let's add an implementation for the function in the CPP file. It returns a void. Now I'm going to list the function name followed by the argument. So, well, there are no arguments, so we just want the function name. But this is a function that's a member of a class. So we precede the function name with the name of the class and then 2 colons. Why is it void? Because it doesn't return a value. So the way we tell the compiler that the function does not return a value is to declare it as returning void. See, it's just like this. This function here is prime, returns a bool. So it returns something. So you'll see in here there's a return statement. Return true. True is a bool. The data type bool is true or false. So here there won't be any return statement because it doesn't return anything. Although we could say return. But
can I ask one more question?
yeah, but do we want to? Is that's not going to get me off on a tangent, right? So I'm not finished yet on this.
Okay.
Yeah.
I need to have 2 bools in the same class.
All right, wait. That's the second question. Let's do this one first, okay? How to add a member function to the class and how to use it. Let's finish that first, and we can go to the other question. Okay. All right. So now that we have now we have to implement it. Whoops. How would we implement it? Well, look here. The class, you know, basically encapsulates this integer that we're calling x, a member variable x. So that's what we want to print. That would be, I mean, we could say something like this. The number is, we could do it like this. You know, we don't have to just print the number. We can, however we want to implement print. But I mean, it should make sense for the class. Now we have it here. Let's test it. Oh my God. This is print. Did I save that? Oh, this is, we need this include. or using cout. That's inside IOStream. But that's not the problem. What the heck? Huh? So here. Thank you very much. Who did that?
You did that.
No, I mean, who you noticed that one? Okay, great. Good job. All right, so that's how to add a member function. Now you've got another question related to bools.
Yeah. I keep overloading a number, class number. I overload it because I try to use 2 bools.
You overload the constructor?
Yeah, overloading. I have about 1,000 bugs.
Oh, that's what you mean by overloading. I see. Overloading is actually a technical term. It means you provide alternative implementations of a single function.
No,
But that's what I thought you were talking about. Let me take a look in lab, maybe, rather than getting into it now. Okay. Let's get back, and want to make sure we have enough time to get significantly into lab 7. All right, so now we're going to talk about arrays and vectors. Reading assignment 6. Is that the last reading assignment? That's it, right? That's great. So this is the last new topic in the class. Arrays and vectors. What I'll do is I'm going to work out problem exercise 1. So it's lab 7, problem 1. Let's start by implementing the test code main. I'm not going to start talking about the concepts yet. I just want to get things kind of set up so we can quickly illustrate the ideas with sample code. So I'm just going to get this main function here. Once again, we don't need this. It's only for Windows. Look at that, I test my by function. There we go. All right, so the idea of a vector and an array. Let's see here. This is, in this exercise, we're looking at a function that takes 2 arguments. The function name is myMaximum. The first argument is an array. The name of the array is A. And the array is, what an array is, it's a fixed container of some data type. It has it's a sequential arrangement of data, all of the same data type. So in this case, we have a sequence of integers. We don't know how long it is, though. It's just some sequence of integers is being passed in to the function. So A represents a collection of integers, a sequence of integers. And the second argument, number of elements, that's the number of integers that are in A. That's how we look at this function declaration. So arrays are about working with collections of things. And vectors, the same thing with vectors. The difference between vectors and arrays is that a vector is a flexible container. You can increase its capacity. You can make it include more objects or remove objects from it. But with an array, you have a fixed number of data items in it, and you can't take them out. They're just, when it gets created, the memory is allocated, and there's something in that memory. So in this lab, what you're going to do is implement three different functions and test them. And these functions operate on arrays and vectors. All right. Here's a function. So here's a function that takes these arguments and then it returns a value. So let's return something. Let's return an integer. Let's just return a 0. So this is a good next step to do. Just put it like that. And then see if you can build it. And run it. No problem. So we can compile this function here, the way it is now. But let's go back and look at what it is that we need to do. So provide an implementation of the myMaximum function, which is declared above. The first argument is an array of int, and the second argument is the number of ints in the array. The function returns the largest int that's in the array. So that's what you have to return. That's what this int is for here. Return. This is getting passed in. This array, it's an array. It's a collection of integers. Give me the value of the biggest one in there. Return that. Write test code that thoroughly tests the function. The test code should use assertions. All right, let's do that. I'm going to do this a step at a time. Let's get ready to do the test code first. Let's write an assertion. So we're going to call, let's do it like this. We're going to call this function, and we're going to pass in some array. I'll call it A1, the A1 array. And it will have 0 elements. But that doesn't make sense. Probably we won't do this. So let's do it like this. Let's do, I'll pass in 1 element. The array has 1 element. And so we're going to assert that myMaximum returns a 0 when it runs with that input. Because A1 is not defined, so we need to define A1. How do we define that? I think this works. I think that's correct syntax. It's a little different in every language, so we just have to try to remember it or play with it until you get it. It built. Let's see if it runs. Actually, by is not a good line to write. Let's put all tests passed. But now let's pass in, if we have an array that has a number, just the number 3 in it, and now we pass in A1 into myMaximum, it should return 3. That's the largest element, right? So My maximum returns a 3, so the assertion my maximum called with A1, that returns a 3, so this assertion should be okay, which is going to fail. We're just going to make it fail because we're returning a 0 here. We're not implementing anything. So this should fail. Let's see what it looks like when it fails. Okay, assertion my maximum equals 3 failed. All right, let's make it not fail. By the way, this is I'm showing you a development strategy. It's called test first software development. So you write your test code first. You write the stubs, and you make your test fail. And then you implement the missing logic and to make the test succeed. Okay. Let's do this. Let's write another test. That's here's another array. We'll call it A2. And we'll have the numbers 3, -2, 11, and 8. So that array has 4 elements in it. This one here? I'm sorry, copy that code. I need to change it to A2. Looks all right? Okay. Give me the yeah, good. Thank you for that question. I want to finish the line. It should return 11. Okay. Let me read this line to you. There's a function call here. Right there. So when you make a function call, you think of it as an expression. It is an expression, and after the expression is evaluated, it's replaced by what it evaluates to, unless it's a void for a function. But in this case, my maximum returns an int. So that expression that I have highlighted, well, I highlighted that parenthesis, and I don't want that. This expression right here, when it runs, when it's evaluated, it's replaced by an integer. It's replaced by the largest integer that's in A2. And that will be 11. And then once we have the 11, we compare it to our 11 here. And that comparison will be true. So the assertion will just silently do nothing. Let me break it out a little bit to make it perhaps easier to understand. We call my maximum with 2 arguments. There it is. I'm going to do this. I'm going to rewrite this. Oops. All right, let's just look at these 3 lines right here. In the first line, we are defining A2. A2 is a variable. A2 is an array. Why do we know it's an array? Because it's followed by an opening and closing bracket. You can call it a square bracket if you want. This is called bracket. This thing here is called a brace. Call it a curly brace if you want. And so A2 is an array because it's followed by an opening and closing bracket. And arrays they only contain a particular kind of data. It could be an array of string, an array of double, an array of bool. It's an array of something. And the something that it's an array of appears before the variable name. So it's an array of int. A2 is an array of int. And now what follows the assignment operator here is the values that the array is initialized to. So this array has 4 elements in it. It has in the first slot it's got a 3, in the second slot it's got a -2, in the third slot it's got an 11, in the fourth slot it's got an 8, and that's it. It doesn't have a 5th slot. And by the way, the first slot is slot number 0, exactly. And the last slot of a 4-element array is slot number 4 minus 1, or 3. It's slot 3. So that's what A2 is. That's how we're defining A2. Now my maximum here takes an array of int followed by the number of values that are in the array. So we call my maximum here. We pass in A2. That's the array of interest now. And we have to tell my maximum how big the array is. Because just getting A2 by itself, the function doesn't know how many elements are in there. That's one of the differences between an array and a vector, by the way. With a vector, you just pass in the vector because the vector is an object. It has a size function in it, and it has functionality built into it as member function. So a vector is an improved version of an array. But this problem deals with arrays. We'll talk about vectors later. So we pass in A2 and 4 into my maximum, and my maximum scans the values in A2, decides which one is the biggest, and then returns that one. And what it returns is assigned. This is the assignment operator. What my maximum returns is assigned into the variable called the max of A2. The max of A2 is an int. So after this, the max of A2 is set to the value that my maximum returns, then we use that in an expression when we call assert. We use it in the expression my max of A2 equals 11. So we want to make sure, this is our test code, we want to make sure that the value returned in this case is 11. I feel like I'm talking too much about this. I know you asked a question about how to understand that function. Is it clear now? Or not? It can't be fully clear, right? But a little more clear. Do you want to ask another question, or do you want to just go forward here? Go forward, okay. So now, once again, we just have a stub here. We're not doing what we're supposed to do. So this should fail as well, okay? So this will also fail. Let's see what it is that we need to do here. We have an array of integers. We have to figure out what the biggest one is. So here's the biggest, I'll say biggest value. Biggest, I'll just call it the max. Let's set the max to be the first element in the array. But actually, let's put an assertion in there. The number of elements needs to be larger. The function doesn't make any sense if there's 0 elements in the array, because what's the maximum value in an empty set? That doesn't make any sense, right? So you can't call the function with an array that has no elements in it. So let's just put an assertion in there just to make sure that that's the case. So that means at least position 0 is valid. So let's start. This function is the max, so we're going to end up returning this max. Let's assume that the first element in the array is the maximum and then return that. So that'll work for this test case here. There's only one element in there, and that's going to be the maximum, so this assertion should be okay. But this one is different. If we take the first element here, it's a 3, and then my maximum is now returning that 3, and that this will fail on this assertion. Let's see that. There it is. The max of A2 equals 11 failed, but the other assertion is okay. What we need to do is, if there's more than one element, we have to check the other elements. So the next index is going to be 1. Let's use a for loop to check all other elements. And we'll start at 1. And we'll continue while the index that we're looking at is less than the number of elements. Now you've got to think about that because there's a one-off error involved there. The number of elements is 1 past the last valid index. That's that one-off situation. I know to do this, I just do this all the time, so I can see this expression and think instantly that it's correct. But you're going to need to think about why that's correct. You could do it like this. You could say, because we want the loop to run while I is valid. So you might think along these lines that, well, the last valid index is number of elements minus 1. So that's the last possible value of I. So you could say I is less than or equal to number of elements minus 1. So you could do it like that. But it's not what you see in practice, because there's a subtraction here, and just people that do this kind of work are used to starting counting from 0. So they would generally do it like this. And then here's the test. So we're scanning across the remaining elements in the array. We're going from 1 to the last one, to the last index. If A of I is bigger than our current max, that means we have a new candidate for the max. So let's record that fact here and continue on. That's the logic right there. Let's start by guessing that the first element is the max. That's here. Let's look at all the remaining valid indices, and if the size of the array is 1, then this for loop won't even run. But if the size of A is larger than 1, then the for loop will run. So what this for loop does is it considers all indices that are larger than 0. All valid indices larger than 0. And if it finds an element in the array that's larger than what we consider to be, is larger than what we've seen so far as the maximum, then we set a new maximum. And then we return that max. So I think this assertion is going to work now. All tests pass. There we go. So you're going to want to include some other test cases. You know, for the special cases, you know, make the maximum the first element, make the maximum the last element, you know, things like that. Well, this isn't bad for test cases. Okay, ready to move on to the next problem. Questions on this? Is this tough?
This is where it gets hard.
This gets hard?
There's a last space
Yeah.
that has a slash and a zero, right?
Say it again?
In the last box, there's a slash and a zero, right? That's why it says -1.
I don't understand the question. You're talking about this code here?
No, in general,
With arrays?
with arrays, yeah.
The last box has got a 0 in it?
Extra box because it has a slash.
No, that's a string. That's a string. A string is terminated by a 0. You know, a single byte string. A string of, so that's a string. That's a C style string you're thinking about. That's a good question. I don't want to get, we don't have time to get into that right now, so I can't launch a lecture into that. Let's look at exercise 2. Now here in exercise 2, where the function that we're implementing takes a vector and not an array, but you'll see the syntax is very similar. The first argument is a vector of int. The second argument is the number of consecutive integers to append to the vector. The function appends onto the vector v the values 0 through n. Hint, use the pushback function of vector to append these values to v. Write test code. All right, with assertions. Okay, so let's get out of this. Let's start building our solution. Here's the function. And we're going to need the vector header, like that. Include vector. Now this vector is defined. Vector is a class. So when we work on a vector, we're working on the instance of a class. An array, on the other hand, is not an instance of a class. An array is a collection of primitive data types. I'm not sure if you call an array a primitive data type. Alright, so we have this, and let's see if that builds and runs. Looks good. All tests passed. Alright, so let's write our first test case. So we have a vector of int, and that's how we do it. We use these angle brackets because actually it's not an ordinary class vector. It's called a template class, and a template class has when you create an instance, when you use that template class, you need to provide arguments when you specify the data type. So this is a form of argument here. It's an int. It's a vector of int. You can have a vector of string, a vector of double, a vector of your number class, and so on. So here's a vector, we'll call it v1 for the first test case. And v1, when we called it like this, the vector is empty. So a vector is a sequence of values. A vector of int is a sequence of ints, just like an array. But it's not fixed in size. And so when you create an instance of vector like this, it's a container of ints, a sequence of ints, which is empty. Now, if we call this function and pass in our v1 and say we want the values 0, we want to append the values 0, 1, and 2 onto v1. Get rid of that comma. So when we're done with this, the array should look like the following. v1 should have a size which equals 3. But go ahead.
What do you mean by append 0, 1, and 2 on v1?
The vector is a sequence of integers. And what we want to do is lengthen the sequence by 3 values. The value 0, followed by the value 1, followed by the value 2. So far, this sequence of values, v1, at this point in the code, is an empty sequence. There's nothing there. So when we're done, we'll have a 0, a 1, and a 2 in it. In fact, let's have it, just to verify our understanding, let's check that the size of v1 at this point in the code is 0. And then we call the function with v1 and 2, and this 2 means append 0 through 2. If we call it with a 3, it would mean append 0 through 3. And that's just the problem statement. That's the way I explained it here. You know, the function appends onto the vector the values 0 through n, where n is passed into the function. That's just the problem statement. It's just an artificial problem that we're solving, just for practice. So now, after we do this append, the size should change to 3. And we want to verify that in each of the positions we have what we think is there. The first position should be a 0. The second position should be a 1, and the third position should be a 2. The third position is position 2. So all of these 4 assertions should succeed. But you won't, right? Because we're not doing anything in here. But the first assertion will be okay. We create v1 and assert that when we invoke size on v1, see, vector is a class, and when we create an instance of the class, we have member functions that we can call. One of those member functions is size, and we call it here to verify that the size of v1 is 0. It has no integers in it yet. Let's see. This is the assertion that failed. So that means the assertion that v1 was 0, that was okay. So this is the assertion that failed right there. That's because we didn't implement the function yet. Let's do that. Let's implement this function. So we want to append the values 0 through n. That's why I have the expression here less than or equal to n right there. Because we want to include n. Appending values 0 through n, that's appending n plus 1 values. Because you've got to add the 1 in there, right? That's that one-off problem again. So we've got the vector v. This is the v that gets passed into the function. We don't say v1. That's in another scope. That's in main. What we see is the v that's passed in. So we're working with v. So let's append onto v. There's a function called pushback, and we just push back the I. So we run I ranges from 0 through n, and just push each of those I onto the vector. Now I think these assertions will all succeed now. Question? Pushback means you've got a sequence of values, that's a vector. Allocate a new slot at the end and put the new value there. So we're appending onto the back of the vector. That's it. Now you're going to need other test cases. And like for instance, start with a vector that's bigger than 0. Let's use pushback to do that. Let's push a -4 onto there. Now the size is going to be 1. I'm sorry, that's not v1, that'll be v2. Let's just put a 4 on there. So we're going to have let's append a 1. Now let's append a 3. That's a weak. No, let's append 1. 1's all right. One problem with using test code is that you got to debug the test code too. That's a big problem with test code. So as you see, I could have forgotten to change those to v2s. Yeah, here we create a vector. Now the vector is just one element, and that shows how it works with one element. Let's do 2 elements here. So when we do the first pushback, when we create v2 is empty. When we push back 10, then we have the vector with just one element, 10. When we call the second pushback on v2 with a -4, then -4 is appended onto the end of the sequence. So now we have a vector that's 10 minus 4. And so on. We could create more test data. And now that v2 is of size, we just modified that. v2 is now of size 2, so that assertion should succeed. Now if we call this function with 1, that means we're appending 0 through 1 onto v2. And I'm going to do it like this. v2 is now 10 minus 4. Wait a minute. That's the wrong direction. 10 minus 4, 0, 1, and 2. Right? So we called, nope, sorry, no 2 there. We called the function with a 1 here, so we're appending 0 through 1. So we already have a 10 and a -4 in there, so just append. Now the size needs to be 4. Make sure that our assertion is fixed on that. V0 is going to be 10. V1 is going to be -4. V2 is going to be 0. And V3 will be 1. And let's check that quickly. We won't be able to do anything more than this. All tests passed. That's it. I'd say for this problem, you know, that's a good amount of test cases for this problem. There's one more exercise, and you'll need to work on that alone in lab. Okay? So we'll see you all. Once again, quiz 2 is on Monday. We'll see you then.